This next video is kind of an introduction to the periodic table. Keep in mind, we just talked about the fact that there are 7 diatomic elements on the periodic table. We know them as nitrogen, oxygen, fluorine, chlorine, bromine, iodine. Oh, and then also hydrogen. And so what we're going to do right now is I'm going to just kind of show you that this thing is the ultimate cheat sheet in the universe. Even in the days when you weren't allowed to use all your resources on exams and stuff like that, if you knew how to read this periodic table, you could really be a mover and a shaker in this class. So that's what we're going to have a kind of a closer look at in just a second here. So I love this slide because it shows a pretty important trend, and it also makes it incredibly obvious, right? So if you imagine that last slide that we just had of the periodic table, you'll notice a very conspicuous thing. You'll notice that just about everything on that periodic table is green, which means it's a metal. So if you're a betting person, you have an element selected at random, it's probably going to be a metal. There are several nonmetals on the periodic table. This will become especially important next week when we talk about the difference between ionic and covalent compounds. And of course, we've seen the fact that hydrogen is just there to drive us crazy. Turns out that the one thing that is kind of on the left side of the periodic table that is a nonmetal is, of course, hydrogen. So there is our hydrogen, but everything else is also a nonmetal over here. So I always imagine this kind of, up and to the left kind of dividing line on the periodic table. Everything with the exception of hydrogen on the left side of that is going to be a metal. And then the nonmetals are going to be up and to the right. And of course, you got this totally wacko purple section called metalloids. They're also called semi-metals. And so we're going to just kind of take a couple of seconds and talk about what makes something a metal and what makes something a nonmetal. So hopefully now you can attach some physical properties having to do with metals, nonmetals, and metalloids. I did want to talk just a little bit briefly about what makes the periodic table so periodic. Well, it turns out that if you take a look at a periodic table and you kind of, like a typewriter, go down one row and then kind of go to the very next row, what happens is that regardless of what property you're talking about, there's kind of this repeating pattern. So I just kind of picked one at random. Don't worry too much about the first ionization energy. It's the amount of energy required to remove the first electron from the outer shell, but we don't care that much about that. What we care about is you'll notice this kind of like periodic thing happening as we kind of go left to right across the periodic table. It seems like that the hardest electron to remove is always in this particular family: helium, neon, argon, krypton, xenon, radon. You'll notice that these are all in a really particular part of the periodic table in just a second. It turns out that anytime that you're in a vertical column on the periodic table, that is called a family. And so what happens is as you go left to right across the table, you get this kind of repeating trend in certain properties as you go from family to family to family to family to family. Another example of that for this particular property is you'll notice that lithium, sodium, potassium, rubidium, cesium, and francium are all kind of like the lowest members of this particular property. They all are in a vertical column on the periodic table. So let's spend a little time and talk about that. Here's a link to the website that I'm going to go to. I believe this is available in lecture supplement slides. So when you click on that link, what comes up is this periodic table that is really helpful to take a look at the structure of different groups. First of all, we should define the fact that anytime you've got a vertical column on the periodic table, that is called either a group or it's called a family. So for instance, there are 4 different groups that I'd really like you to be able to recognize. One is the alkali metals. And so you can see that all of those metals are in a vertical column on the periodic table. So if you ever hear me refer to the alkali family or the alkali metal family, I'm talking about kind of, if you think about the periodic table as goalposts, I'm talking about the one that is on the farthest left goalpost here. I'd also like you to know the position of the alkaline earth metals, which are pictured right there. And one of the things that we talked about just briefly a couple of minutes ago is this idea that properties on the periodic table are periodic, right? And so it turns out that if you are a beryllium atom, you are most like a magnesium atom. In fact, you're much more like a calcium atom than you are from somebody from a different family, like a lithium atom, right? And so this is kind of how I think about periodicity. So if you go in kind of a horizontal row, right? So for instance, you see that 2 right here, right? We highlighted everything in what's called the second period, right? And so we've got periods that go left to right, and we've got families and groups that go up and down. And to me, a much more important classification to understand is that idea that things in a vertical column are always considered families or groups. So here's our 3rd period, the 4th period, 5th period, 6th period, 7th period, etc. So 2 important concepts: family and groups, which are vertical columns, going across in a row, that's called a period. And so as we go from, let's pick out period 3 and move from left to right, I go to different families. So there's the alkali metal family, there's the alkali earth metal family. 2 other families or groups that I'd like you to know, even though only one of them is highlighted on this particular slide, are the noble gases, right? And remember that on that very last slide of periodicity, we saw that these guys, for whatever reason, it's really hard to remove an electron from those guys. But if I ever talk about noble gases or the noble gas family or the noble family, we're talking about that column. And then it turns out this next one, for whatever reason, doesn't highlight very well, but it turns out that this group 17, right? So if we number all the columns on the periodic table from 1 to 18, turns out that group 17 that's right here, right? Those are considered halogens. So one kind of interesting thing we already know about halogens is that they tend to be diatomic in their elemental state, for instance, you might say. I will say that you don't have to worry about the names of any other families in this class. Really, if you think about the goalposts of the periodic table, those are the important ones. I would like you to know a couple of different regions of the periodic table, however. One is the transition metal region. And so if you kind of imagine going from left to right across the periodic table, you pass through this kind of narrow region of the periodic table, and these guys are called transition metals or transition elements. You also have things like the lanthanoids and the actinoids, and even though these are not any regions that we're going to talk about a whole bunch, it is really important that you know why they happen to always be kind of left off of the periodic table. They kind of just exist way down at the bottom here. It turns out because really we shouldn't be talking about a periodic table. We should be talking about a periodic scroll. It's just really hard to print that out on a single piece of paper. So chemists have kind of taken these lanthanides and actinides, and these are sometimes called the inner transition elements, but they've taken them out so that we can kind of condense the periodic table a little bit. Another thing which is pretty common is somebody will ask you about the metalloids or semi-metals, so you can certainly refer to this website anytime you go there. Of course, these are the ones that kind of have those intermediate properties between nonmetals and metals. They're also really popular in like cell phones and different electronic devices and computers and such because they have some really interesting properties. And the other one, which isn't actually on here, is if you ever hear your book, or I might talk about what's called the main group elements. And so the main group, or sometimes called representative elements, I think that might be what your book calls them, are anything except for the transition metals and the actinides and the lanthanides. So like, for instance, these are all main group elements or representative elements because they are not in the transition metal region. These also are considered representative elements. So I just wanted to include this as a summary slide. make sure that you can find certain regions on the periodic table, including the metals, metalloid, and non-metal areas. Make sure that you can find the transition metals, and also the inner transition metals, which include both the lanthanides and actinides. And then in terms of the families or vertical columns on the periodic table that I'd like you to be able to recognize, that includes the alkali metal family, the alkaline earth metal family, the halogen family, and also the noble gas family. Once you have kind of an idea that these properties tends to propagate as you go across the period, that gives rise to a couple of different periodic trends that I'd like you to know about. One is atomic size. And so this chart includes kind of the relative sizes of these different atoms. Again, we'll be talking about atomic structure. Periodic trend, if you'll notice here, the biggest elements seem to be on the lower left bottom of the periodic table. And then the smallest elements are up and to the right. And this is something that you see quite often, is that whatever property you're talking about, as you kind of go top right to bottom left across the table, it tends to either increase or decrease. In this case, if we're talking about atomic size and we go from right to bottom left, you get a bigger and bigger element. It turns out that there's other ways that we can represent this. Here's just kind of a different way of looking at these different columns on the periodic table. You'll notice that the biggest elements tend to be at the lower left. The smallest tend to be at the upper right. Another couple of trends that you should probably know about is as you go left to right across the period, you'll notice that size gets smaller and smaller. And again, once we start to talk about electronic structure, this stuff will start to make a lot more sense. Also, going down a group, no matter where you are, tends to increase atomic size. So here's just a summary of that, right? Atomic size or atomic radius tends to get bigger as you move down into the left on the periodic table.